Given the fact that it takes an amount of heat, Q, to warm up an object to its melting temperature and then to melt it, and not warm it up beyond that, we're supposed to find out what the latent heat of fusion is. I'll call it L sub F. It's identical to the latent heat of melting, which might be would be a more appropriate name for the case at hand, but they call it that. Let's go with that. So the given amount of heat Q has got to be equal to the amount of heat it takes to warm it up to its melting temperature. I'll call that Q1, plus the amount of heat it takes to melt it at the melting temperature. So I'll call that heat warm up the object from TO to TM, and then this is the heat to melt object. From our definition of specific heat, and they were careful to say specific heat, not specific heat capacity, so I need a big C there. Q1 is just the heat capacity times the change in temperature, and then Q2 is the mass of the substance times the heat per mass required to melt it. So the change in temperature is the final temperature. Okay, for this stage I'm just warming it up to Tm, so that would be Tm minus the original temperature, which was the TO, which they called room temperature, and plus the MLF. And at this stage it's just algebra. Just going to solve for LF. I think I'll subtract this piece from both sides and switch sides. So my right side would be MLF, but switch that over to the left, and the left side would have been, without the switch, Tm minus TO times the capital C there. Okay, just divide both sides by M. And I've got the desired expression for the latent heat of fusion.